Newton's first law states, an object at rest stays at rest, and an object in motion stays in motion with the same speed and the same direction unless acted upon by an unbalanced force. Before getting into the demonstrations of Newton's first law, one must understand four simple definitions: inertia, mass, weight, and volume. Inertia is the impulse of an object to resist any attempt to change its velocity. It can also be summarized as a resistance to acceleration. If you have a 100 kilogram mass and a 15 kilogram mass, the 100 kilogram mass will move much slower than the 15 kilogram mass. This is because the 100 kilogram mass has a greater mass, so it has a greater inertia, while the 15 kilogram mass has less inertia.
Alright, next is mass. Mass is the universal measure of inertia, usually in kilograms. To distinguish mass between different objects, students can compare weights and how much space they believe the object takes up. Next up is weight. Weight is the mass of an object times the gravity of the area. The equation for weight is W equals mg, or weight equals mass times gravity. The gravitational pull on Earth is 9.8 meters per second squared. The gravitational pull is approximately 10 meters per second squared. So for an object with a mass of 15 kilograms, the weight would be about 150 newtons. And for an object with a mass of 100 kilograms, the weight would be about 1,000 newtons.
Now volume.
Volume can be defined as the amount of space an object takes up.
As you can see in this example, you have two pieces of paper with the same amount of matter, but when one's crumbled up, it has a different volume. It has more volume than the flat piece of paper. This is because it takes up more space. Demonstration 1.
You may have noticed that the marble began to roll around in the container as the car moved. The motion of the marble represents Newton's first law, which indicates that an object will not accelerate unless a net force acts upon it. When the car is not moving, the marble was at rest. As the car began to accelerate from 0 meters per second squared, the container also accelerated with the car. However, the marble was not attached to the container or the car, and therefore did not accelerate with them. The marble's inertia tried to keep the marble at the same velocity until the force from the container's walls on the marble forced it to move forward with the car and the container. This results in what appears to be the marble rolling to the back of the container, when in reality the marble is staying still and the container is moving forward with the car.
Demonstration 2.
Now watch very closely as the person jumps onto the trampoline. Pay attention to the position of the leaves. As you notice the leaves while she's jumping in, you'll see that they stay level when her feet sink into the trampoline.
The motion of the leaves on the trampoline helps show how Newton's first law affects everything. The leaves on the trampoline are at rest before the person jumps onto the trampoline. Once the person's feet hits the trampoline, the surface of the trampoline collapses downward under the force of gravity acting on the person's body. However, the leaves did not have a net force acting upon them in that instant and attempted to stay at rest and in their same position. Remember, according to Newton's first law, an object will not accelerate unless acted upon by an unbalanced force. Eventually, gravity acting upon the leaves forced them to fall down to the surface of the trampoline, but this demonstration proves that Newton's first law still applies to this scenario.
After knowing basic knowledge, let's see if you can apply the right concept.
You put your book on the bus seat next to you. When the bus stops suddenly, the book slides forward off the seat. Why?
Study the motion of the textbook as the car changes speed.
A net force acted on it. No net force acted on it. It remained at rest. It did not move, but only seemed to. Gravity briefly stopped acting on it. No net force acted on it.
Congrats if you got it right. If not, let's explain the scenario. The textbook is on the seat of the moving vehicle. As the car is moving, the textbook is moving at the same rate. Because the camera view is inside the car, the perspective causes the textbook to appear at rest. As the vehicle comes to a sudden stop, you see that the book flies forward from its original position. There are no horizontal forces acting upon the textbook, so the net force of 0 allows the textbook to keep moving forward as the car quickly decelerates to rest. Once the book flies off the seat, the normal force is no longer acting upon it. The textbook is then in free fall because gravity is the only remaining force acting upon the textbook. This happens because the textbook has inertia trying to keep it at the same constant non-zero velocity.
I thought we were waiting right when we got out.
That's what I... Get it, Victoria! Oh!